Okay, now we're going to go over how to graph some of the special cases. So we've gone over before what a Hoy is and what a Vux is. Okay, Hoy stands for Hoy, stands for horizontal, zero slope, and the equation starts with a y equals. So when you graph a Hoy, it looks like this. It's a horizontal line, it's a horizontal line, and the slope is 0. A Vux, on the other hand, is a vertical line and has an undefined slope. So here we have examples of Hoys and Vux. So if you see an equation like this that just has y equals a constant, that is a Hoy. You know it's going to be a horizontal line. You know it's going to be a horizontal line that goes through the value where y equals 5. So I go up 1, 2, 3, 4, 5, and I draw a horizontal line. And I know my slope is 0. Here, it's another Hoy because it's y equals. I go to where it's -2. I draw a horizontal line, and I'm done. That's y equals -2, and I know the slope is 0. This is another Hoy, y equals 4. I go up 1, 2, 3, 4, draw a horizontal line, and I know the slope is 0. So those are examples of the Hoys. Very easy to graph if you remember what to do. Now let's look at some of the Vuxes. So this is when you just see x equals a constant. So as soon as I see x equals a constant, I'm going to write Vux because I know the V in Vux stands for vertical. So I find out where 1, 2, 3, 4, x equals 5, and I draw a vertical line. And I know the slope is undefined. So for x equals -4, I know that's a Vux. I go 1, 2, 3, 4, draw a vertical line, and I know that's an undefined slope. X equals 3, I go 1, 2, 3, draw a vertical line, and I know my slope is undefined. So again, when you see an equation and it's just y equals a constant or x equals a constant, you know that those are special cases and you think of the words Hoy and Vux. So this next page you're going to be doing for homework, just practicing that. But we're also going to go over today is solving for y. And when you solve an equation for a different variable, so here you might see this equation, which is in standard form, 2x plus 3y equals 6. I want to solve this equation for y. Now, when you used to solve for y or for x, you wanted to isolate whatever variable you were solving for. We're going to do the same thing here. What's different, though, is instead of getting just one number, you're going to get it equal to something in terms of x, and that's okay. So this tells you this is a linear equation in standard form. If I want to graph this equation, the easiest thing for me to do is to put it into slope-intercept form because I know how to solve it from slope-intercept form. Now, slope-intercept form, I know how to graph it, is y equals mx plus b. So I want to get the y all by itself. So the first thing you do is you isolate the term that contains the y. So in this case, to isolate that term, what I want to do is I want to subtract the 2x. If I subtract the 2x from the left, I have to subtract the 2x from the right. But now, notice I'm not writing 3y equals 6 minus 2x. And the reason I'm not going to do that is because I want it in this form. I want the m first. So I'm going to write -2x plus 6 because this is looking closer to what I want. Now I'm going to divide everything by 3 because I want to isolate the y, and I get y equals negative 2/3 x plus 2. Soon as I do that, I know now my slope equals negative 2/3 and b equals 2, and I know how to graph it. So if you're given an equation in a form that's other than slope-intercept form, you can just solve that equation for y. And when you solve it for y, you're putting it into slope-intercept form. So let's try another one. So here's another equation. 3x minus 2y equals 12. This is what we call standard form. I want to isolate this term. I want that all by itself. So what am I going to do to get it all by itself? I'm going to subtract the 3x here. So now my negative 2y is all by itself on the left. But the rule says if I subtract from the left, I have to subtract from the right. Now, I could write 12 minus 3x, but I don't want to because I want it in the form of y equals mx plus b. So I'm going to write negative 3x plus 12. So now I'm almost there, but I don't want to know what negative 2y is. I want just to be y. So I'm going to divide this by negative 2, and now I just have a y. But then I also have to divide this by negative 2 and this by negative 2. A negative over a negative is a positive, and this is minus 6. So now I know my slope is 3 over 2, and my y-intercept is negative 6, and I know how to graph this equation. Okay, let's try one more together, and then you can try the next two on your own. So here, the term I want to isolate is negative 4y. I want that by itself. So to do that, I'm going to subtract 2x. And I'm going to subtract 2x from both sides. But when I rewrite it, I'm going to write negative 2x plus 8. Now, I don't want it to be negative 4y. I want it just to be y. So if I divide by negative 4, that's just y. I have to divide this by negative 4 and this by negative 4. So I get y equals, this simplifies to 1/2 x, and it's going to be minus 2. Now, notice this 1/2 x, this 1/2 x can be written many different ways. I can write it just like I did 1x over 2. And if you look at that, that can also be written as 1/2 x. And it actually can also be written as x over 2. One way that it can't be written, though, is you cannot write it as 1 over 2x. Okay, so now I want you to stop the video, and I want you to try 3 and 4 on your own, and start it again, and you can watch me do it and check and see if you're right. Okay, so here the first thing I'm going to do is subtract 5x and subtract 5x. I'm going to say 2y equals negative 5x plus 8. Divide by 2, divide by 2, divide by 2. That becomes y equals negative 5/2 x plus 4. And again, the negative 5/2 x could be negative 5 over 2x. It could be 5 over negative 2x. It could be negative 5 over 2x. It could also be negative 5x over 2. I prefer this way. Okay, then number 4, I subtract 7x, subtract 7x. I get negative 2y equals negative 7x plus 10. Divide by negative 2, divide by negative 2, divide by negative 2. And I get y equals, a negative over negative is a positive, and a positive over negative is a negative. So I get y equals 7/2 x minus 5. Okay, and that's the end of this video.